have a look at this. We know the properties of quadrilaterals, but we're going to be using the properties of quadrilaterals to kind of get an idea of what this means. Okay, so we're going to be looking at proofs. Okay, we're going to be looking at proofs, and we're going to be using them. We're going to be using them to prove that quadrilaterals are the certain quadrilaterals. Give me 1 second. Oh, Maria is throwing, okay, and my thrower and Lysandra need to focus. Okay, all right, we're going to be using these properties to see if we can prove that this is a parallelogram. Now, we're looking at all the properties that they've given us over here, 1, 2, 3, 4, 5, and 6. And they want us to know, us to decide whether each piece of given information alone, just the piece of given information alone, is sufficient to prove that this quadrilateral ABCD is in fact a parallelogram. So we're going to look at the properties that they've given us over. Now it says here that E, number 1 says that E is a midpoint of AC and BD. So they're telling us that E over here is a midpoint of A and C. So the midpoint over here, and it's also the midpoint of B. Now we have to decide whether this is enough information for us to prove whether this is a parallelogram. Now, let me just ask you that. If E is my midpoint, what does that tell me about AE and EC? Tell me in the chat. What does that tell me about AE and EC? If that's the midpoint, what does that tell me about both of these? That's it. David, you're off to a good start. Can you follow? 100%. It tells me that AE is equal to EC. Also, because this is the midpoint of BD, what does that tell me about BE and ED? That they are also equal. Good. BE and ED are also equal. Now, what this tells me is that somewhere in the middle, because this is the midpoint of both of them, the diagonals need to bisect. They need to cut through each other, just like cut through. Is this enough of a property of a parallelogram to tell us whether we can use that to prove if this is a parallelogram? Let's go have a look. Let's go have a look. The parallelogram says that in order for this to be a parallelogram, they must bisect each other. So yes, 100%. If we can prove that AC or E is the midpoint of AC and BD, and if we can prove that BE and ED are equal and that AE and EC are equal, yes, E being the midpoint of AC and BD, that's enough. That's enough information for us to say that that is indeed. Now let's think about this next one. Let's look at number 2. Number 2 says angle. So this M over here just means angle, okay? Angle ABC, and remember how we map angles? We're going to go AC, so it's going to be this angle over here, plus angle BCD, so we're going to start here, BCD, this angle over here. Both of them together equal 180 degrees. Tell me yes or no, guys. Do you think that's enough information for us to prove that that's a parallelogram? Think about anything that could possibly make up 180 degrees. Okay, good. I'm glad we're all on the same page, right? And I can already think of one example that's going to give us a problem. What if ABC is 90 degrees and BCD is 90 degrees? Here's what's happening, Tiana. If those two things are 90 degrees, what kind of shape am I actually going to get? Am I going to get a parallelogram? If if this angle B is 90 degrees and the angle C is 90 degrees, am I going to get a parallelogram? No, I'm not. I'm going to get a rectangle. So it's no longer going to be a parallelogram. So this question 2 is not enough information on its own to prove that this is a parallelogram. Okay, stronger, if you're a little bit confused, the reason for that might be that we are on lesson 4 of 6 lessons. Okay, which means you've missed lesson 1, 2, and 3. Okay, but please be a little bit more detailed, okay, on where we've lost you. I saw 2 other people say I'm confused. Can I ask you to either raise your hand and ask me a question now before I continue, or to pop a question in the chat, just so that I don't leave you guys behind. Anybody? Yes, Tiana, where did I lose you?
Ma'am, so you
Yes.
lost me when you said that it's 90 degrees.
Okay, so let's look at this statement. Let's look at the statement, Tiana. The statement says that these 2 angles here at the bottom need to be equal to 180 degrees. Yes?
Yes.
That's what we're saying. Now, does it mean that if this angle, let's say for instance, this angle B was 90 degrees and this angle C was 90 degrees, what kind of shape am I drawing?
A rectangle.
A rectangle. And the 2 angles are going to add up to 90 degrees, I mean to 180 degrees. Do you agree with me?
Yes, ma'am. It's
Is my
90 degrees.
shape is my shape still a parallelogram?
No.
No, it's not. So this bit of information is not enough for us to prove that it's a parallelogram. You understand what I mean?
Yes, ma'am.
We need more information. We can't just use it. Because the fact that the 2 angles add up to 180 degrees, I can use that also in a triangle. Oh, I'm lying. In another quadrilateral. Okay, I can use it in another quadrilateral. This is not enough information just on its own to prove that this is a quadrilateral. This is a parallelogram. So this one is a no. This one doesn't. Okay, I hope that's making sense, guys. Okay, I hope that's making sense. Let's look at this next one, and we're going to try and take it a little bit slower so that we don't get lost. Okay. This next one says that line AB is parallel to line C or DC. So what they're saying is AB is parallel to DC, and line BC, yes, you can just write yes or no. Is it enough or is it not? Okay. And then it says BC is congruent or equal to DA. So we say BC is equal to DA. Yes, Jasmine.
Won't it not work because the purple lines you added on, it wasn't given?
Well, in this case it was. In this case it was. Because they're telling me that AB is parallel to DC, I'm just representing it on the drawing. Okay.
Are
So
we
they've
allowed
given me
to do that?
Yes, absolutely, you're allowed to do that. If they've given you the information, you can put it on the diagram. Okay.
Oh,
I want you to just look at something, Jasmine, that I'm about to do. If they tell me that these 2 are parallel, what do I know about the parallel lines? What do they tell us about? What do parallel lines bring up? And we speak about this every day. Yes, Tiana, absolutely. Jasmine, what? Bring up the fun angle. So that automatically tells me that this angle is going to be equal to this angle.
yes.
Right. So now, if I've got that angle and that angle equal to each other, okay, now I've got an angle and I've got a side and I've got an angle and I've got a side. What do I know about AC in both of the triangles that I've drawn here? What do I know about AC?
The angles are equal.
Angles are equal, yes. What do I know about line AC though? If I look at this triangle and I look at that triangle, what do I know about AC? It is
Common because of
Yes.
line E.
Absolutely. So can I use this information to prove that these 2 triangles are congruent?
Yes.
Yes, absolutely. It's side, angle, side. So I can use this information to prove that this is a parallelogram. So number 3 is a yes. So we just need to think about it in a little bit of a different way. Do you see what I mean?
Yes.
Okay. Well, I'm going to show you something with the next one that we do as well. That's not going to fit like that. All right. Yes, Tiana.
So, ma'am, ne?
Yes.
And if they tell us now it's congruent, ne? And is it ever like us having to prove the congruency? Like, are we ever gonna have to prove it as well?
Yes. Yes. Because that's how you prove that it's a parallelogram. If both sides are equal. So here's what's going to happen. This side and this side in a congruent triangle are going to be equal. But that's also a property of a parallelogram. This side and this side must be equal. And if you prove that they're congruent, this side and this side are also going to be equal. That's another property of a parallelogram. Right. And then if we prove that this is common, that's a diagonal of a parallelogram. So when we're proving for congruency, we are simultaneously proving for the parallelogram. Does that make sense?
Yes, that's why we did congruency first.
Absolutely. That's why we did congruency proof. Because the one side being equal to the other side is the same property that we use for the parallelogram. You understand what I mean?
Yes, ma'am.
All right. So we know that number 3 is going to help us. Let's look at number 4. Let's look at what number 4 is saying. It's saying angle ABC. So I'm going to map it out. ABC. This angle over here is equal to angle ABC. That is ABC. This angle over here. And then it also says angle BAD. BAD. This angle over here is equal to angle BCD. BCD. This angle over here. Without us even having to go back up and look at the properties of parallelograms. Is this enough information for us to prove that it's a parallelogram? Yes or no? Absolutely, Rita. Yes, it is. Because we know that the opposite angles of a parallelogram need to be equal. They must. They must be opposite angles. Okay, this is one of them. Here it is. 2 opposite pairs of equal angles. So that's enough information for us to say that that's going to be a parallelogram. All right, so there we go. That's one of them. Let's look at number 5 quickly. Because we had a real fight in the other class about numbers. So triangle ABE is congruent to triangle AE. Let's map these out. Triangle ABE, close triangle, is congruent to triangle DCE. I'm starting here. DCE. Now, if we look at these 2 triangles, I just want to draw it nice. Never mind. Hey guys, I'm not an artist. Nah. You guys know me and my auntie drawing. Okay. Now we can use the idea that we have last time about making sure that each of the sides match. Right. So we can go AB. Which side should AB be equal to if they're parallel? If they're congruent. Good. Yes. Yes, Rita. That's it, Namani. AB should be equal to BC. So we can say, okay, AB is equal to BC. And then if we go to the other side, we need to go to BE needs to be equal to which side? BE must be equal to DE, according to this, DE. So BE must be equal to CE. And they're also saying that AE must be equal to DE. Okay, so now they're telling us that BAE, 1, 2, 3, must be equal to DE, 1, 2, 3. But guys, hold on. Hold on 1 second. Before we even continue here, let's be for real. Let's go back to the very beginning. Let's go back to the very beginning. where we saw that E is our midpoint. If E is our midpoint, what do we know about this side and this side? They must be what? What must they be? That's it. Not common number, they must be equal. They must be equal. But look at what this congruency has done for us. Are these two sides equal to each other? Are they equal to each other? Are they equal? Absolutely not. Chimweme, look, this one has 3 lines. This one has 2. Okay, that one has 3 lines and this one has 2 lines. So no, they're not. That's okay, Chimweme. We're learning. So no, they're not equal to each other. Same with this side. Look, BE is supposed to be equal to ED, but this one has 2 lines and this one has 3 lines. So this proves to us that there are 2 triangles that are congruent. But are these 2 triangles going to prove to us that this is a parallelogram? Is that going to help us? Yes or no, guys? No, absolutely not. Because they are in the opposite, they're sitting in the wrong place. All of them are sitting in the wrong place. So this is not enough. This could maybe be for a triangle or a square, definitely not. Definitely not for a parallelogram. Let's look at the last one over here. Let's look at ABE, triangle ABE, ABE. Look at the order that I did it in. And triangle CDE, CDE. All right, let's do the same thing we did before. AB must be equal to which side? So AB is equal to which side, guys? Good. Rita, you're on point today. CD or DC, it doesn't matter. Good. AB must be equal to CD. Let's do the last 2. BE must be equal to DE. Good. Must be equal to DE. So this side, BE, must be equal to DE. And the last one, AE, must be equal to CE, 100% CE. So AE, 1, 2, 3, must be equal to C, 1, 2, 3. According to this first statement, is this one true? Is this one true? Is this enough? Do we have enough information here? Absolutely, we do. Because this one proves the congruency in the way that we. So this one is also of that. Okay. So it takes a little bit of thinking and looking at the properties of these to understand what's happening. All right, just need a thumbs up. Do we understand what we mean when we say that there are certain properties that prove a quadrilateral? Does this make a little bit more sense? Excellent. If you're lost, we're going to try and put it together in just a little bit. Okay. Excellent. All right. I'm seeing all of that. Like, okay, ma'am, 8 out of 10. We're going to put it together. All right. So here's the last thing we're going to learn before we continue. We're going to learn this mnemonic, or what is it called? An acronym. Yes. Okay. It's called cpctc. You have to keep it, write it somewhere in your book. Write it down somewhere on your notes, cpctc, and this stands for corresponding properties of a congruent triangles. Congruent triangles are congruent. It was like, what's that? Okay. Here's what this means. Okay. Here's what it means. Is that if I prove, let's say for instance, I prove that angle B is equal to angle D. And then I prove that side AB is equal to side CD. And then I can see that BD is common. That already tells me that triangle ABD is congruent to triangle CD. Do you guys agree with me? Give me a thumbs up if you agree with me. If I can prove these things, okay, even give me a thumbs up and tell me what kind of proof did I use? What kind of proof did I use here for congruency? Is it SSS? Is it AAS? Which one was it? I've got a side, I've got an angle, I've got a side. Which one is it? It can't be SSS, Rita. Look, I'm using an angle. Stands for congruent. Okay, good. I used SAS. You can see it. SAS. Okay. Who's the text is like, man, please write that properly. Okay, let me write it properly because now I'm starting to feel bad. Okay. 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 So it stands for corresponding properties or parts. You can use either properties or parts of, okay, so corresponding properties of congruent, that's the third C, triangles, that's the T, triangles are, I'm just going to add an R here, are congruent. Okay. Okay. So what this is actually telling me, guys, is let's say, for instance, I use the side angle side proof to prove that these two triangles are congruent. If I use side angle side and I use side angle side, right, that's SAS. Because I know that these two sides are congruent, or these two triangles are congruent, what does this tell me about AD and BC? According to cpctc, what does that tell me about AD and BC? Automatically, because I've proven congruency. What does that tell me about those two sides? That they are what? That's it, Liabona. Not parallel, that they are equal. Good. It tells me that they are equal according to the congruency that we've already proven. We now know that this side is going to be equal to this side. That is more than enough for us to prove that this is a 9. It's not even. This is not enough. It's just almost enough. Almost enough. Okay. Then that is going to help us to prove that those two sides are equal. Then if I can prove that this angle over here is equal to that angle over there, because of cpctc, we know that A is going to be equal to angle C. Because of that, then I can already say, because of all of that, this is the parallelogram. Okay, that's what that proves to me. So once I've proven that two triangles are congruent, everything else about the two triangles becomes true. Does that make sense? I hope that makes sense to everyone. If we can prove congruency, everything about the two triangles on either side or either angle comes. Okay, and that's what cpctc means. All right, let's put this into practice because we can't just leave it. Now, here's the information they've given. They said we have been given that AB is equal to, we're going to say equal to rather than congruent to line CD. It means the same thing. They are congruent, meaning that they are equal to each other in respect to one or other triangle. Okay, so they're saying that AB is equal to CD. What they're telling me. They're also telling me that angle, this is the angle, this is what they use in America for angle. Angle CAB, so we're going to go CAB. So this angle over here is equal to angle ACD. So we're going to go ACD. D. That angle over there. Those two angles are equal. Okay. Now, there are many things that we can do with the information that we've been given. They want us to prove that ABCD is in fact a parallelogram. So we're going to do a statement and reason section. I'm going to do statement. All right. Now, I need to start with the information that they've given me, because that just makes it easier for me to kind of understand who's going with what. So I can then say my statement number one, that AB is equal to CD. My reason is that it's given. They've given it to me. I don't even have to stress too much about it. The other information they've given me is that angle CA with the capital B is equal to angle ACD. That's also given. Right. Now, there are a couple of things that we can figure out from what they've given us that's going to help us prove that this is a quadrilateral. Does anybody want to venture for me? What else can we do? Where else can we look to see whether this is going to be a parallelogram or not? Anybody seeing anything on the screen? Okay, BC is equal to AD. No, it's not given to us. It's not given. Liabona, I agree with Loken when he says that AC is common. Loken, you are 100% correct. Jasmine, what's it?
E is the midpoint.
Absolutely. E is the midpoint because it bisects both of these lines. Wow, excellent. I'm going to use both of those points. Okay, I'm going to start with Loken's one. Okay. We're first going to say, before we can even say it's common, Loken, we need to say in triangle, and then we need to map them out, because we can't just say that things are equal. Okay, we can't just say that things are equal. And so you can't say BC is equal to AD. It's not given. They didn't tell us that. They have not given it. We have to say in triangle BAC, I'm going to write triangle BAC and triangle. Okay, I started at B, so I need to go DC, A, just to make sure that my congruency is 100%. In triangle, BACCDA, okay, and then I'm going to write here, just to make sure that we're doing the right thing. Statement 1 and statement 2 are given above, because that also helps us with our proof. They're given above, and then we can say that AC is common. Is common in both of these triangles. Yes, Tiana.
Man, so what if we say, I can't see. What if we say BD is common? Does it still?
Yes, you can. Okay. You can say that. Here's my problem, Tiana. If I say that BD is common, that means I'm working in this triangle. And my problem with that is I don't even have a full angle over there. You see how I only have half an angle? Where did this part go?
I see.
So it's going to be a little bit difficult for us to prove anything in those triangles. Let's open.
Excuse me, ma'am. So, when we say that it's common, before we say that, we have to map out the triangles. I'm just
Absolutely.
okay then. Thank you, ma'am.
It's common, but what is it common in? Where is it common?
Okay. Okay. Thank you, ma'am.
We need to be very careful about that. You can't just say it's common. What is it common in? It's not common in the parallelogram. We don't even know that it's a parallelogram. We're still proving that. So we must map out the triangle. Okay. Now we know that AC is common. If we use, Nicola says, why did I write 1 plus 2? I'm taking the fact that this statement 1 and statement 2 are given above. Okay, that's what I mean. They are given above. Now I have 3 reasons why I can say that triangle BAC and triangle BCA are congruent. I can therefore say that triangle BAC and, is congruent. Is congruent to triangle BA. That's why I'm using that above. Okay, can you follow? I hope that makes sense. Okay, what is my reason, guys? What reason are we going to use for congruency here? That's it, Gift. Well done. That's it, Rita. That's it. The reason I'm going to use is S. That opens up a whole bucket of things. What does that tell us about the rest of the shape, guys? What do we know about the rest of the shape? Let's go ahead and use it. Okay, let's use this. What other sides do we now know are equal to each other? Which other sides are now equal to each other? Think about it. Because these two triangles are congruent, now we can say, Nyeleti, you angel, you, 100%. We can say that BC is equal to AD. And my reason here is going to be congruent properties of, corresponding properties of congruent triangles are congruent. There we go. We can then use cpctc because we've proven that they are congruent, therefore everything about them is equal. Anything else, guys? What else? What else can we prove? What else? We know that BC is now equal to AD. What else do we know? That BC, Notano, you've got it the other way around. BE and ED, no, Namani, that's not information they give us. I would like you guys to pay attention to the angles. No, you cannot just write congruency. No, you have to write CPC. I want you guys to pay attention to this angle. Which other angle is that one equal to? BE is not common. That's it. Tiana's onto something there. Angle B is now automatically equal to angle of CPCTC. Angle B is equal to angle D. Same reason. CPCTC. Now let's have a look at all the information we have, guys. Is this enough information for us to say that this is a parallelogram? Do we have enough information? Absolutely, we do. And then we can say, therefore, ABCD is a parallelogram. And our reason for this is going to be properties of a palm. Now, we can't just say properties of a palm. We need to state them. Okay, now I'm lying. Now I'm saying properties of a parallelogram. Even me, I'm lying. I can say opposite sides are equal. Opposite sides of a parallelogram are equal. Yes, don't laugh at me, though. Also me. Opposite sides of a parallelogram are equal. Opposite angles of a parallelogram are equal. I'm paraphrasing, guys. You need to write opposite angles of the palm, and then you can do the equal sign. So you must add in the parallelogram part. Okay, so we need to make sure that we're naming the properties that we do. Okay, can I just get a number 1 to 10? How do we feel about what has just happened over here? Palm is the shortened version of parallelogram. Okay. Yes, Abigail, yes, that's correct. Okay, what does palm mean at parent? Yes, up to it, that's the thing. At your school, you're allowed to say properties of a parallelogram only after you've proven that it's a parallelogram. Here's the kicker up here, and I'm going to explain this in just a second. Okay. I'm going to explain it in just a second. Okay. I'm sorry, Tavisile. I'm sorry. Yes, Tiana.
Ma'am, so,
Yes.
there's a lot of work to do in the brain. How do we know now how much reasons must we have? Like, this congruency now. How do we know?
Just until you have enough properties, to make sure that it's a parallelogram. Remember, we looked at this part over here. Okay, We looked at this part here at the beginning. So if we can even prove that one of the sides is parallel, which we can, we could easily say that because angle A is equal to angle C, that is the converse, it's the converse property of parallel lines. Okay, we could have easily said that. If we could say that and that are equal, then that if because they're equal to each other and they have a transverse line between them, we can say that AB is parallel to CD. If you had said that, that would have been enough information because we already know that AB and CD are equal. So it depends on which information you put in your. Do you understand what I mean? Okay. So if we had stopped, I know. If we had stopped here, my sweetie, this wouldn't have been enough. If we had stopped just here, we wouldn't have enough information because what I've drawn over here is also the property of the square, a rectangle. So we need to take it a little bit further. Okay.
So what about the E being the midpoint? Like the midpoint don't need to be involved.
Not in this proof. And the reason why not in this proof is because they didn't tell us that E is the midpoint. What if E was actually the point over here?
No.
They didn't tell us that it's the midpoint, did they?
Okay, thank you, ma'am.
We can't just assume E is the midpoint. We can't say that. Okay, Aviani, what's up, my sweetie? Aviani? Oh no. All right, Aviani, when you get ready to unmute, we'll take it. All right, let's have a look at this next one. I think I'm way too close to each other, and I really need them to not be so close. Hello, Aviani.
Ma'am,
Yes.
I'm lost when you wrote 1 + 2.
Oh
And then-
no, my sweetie. What I meant was it doesn't mean two. I was actually saying 1 and 2. So I was saying statement 1 and statement 2 are given above. That's what I mean. Okay. That's all I was trying to say. Okay.
Oh.
That's all.
Okay,
I
thank you.
wasn't trying to confuse anyone. I was just saying statement 1 and statement 2 have already been given to us. Okay, I'm sorry about that. I will bear that in mind, and I will do it better. I'll do it better, guys. All right. The information we've been given in this one. This one also says ABCD is a parallelogram. Parallelogram. Now, here we go, Tiana, the very question you were asking. It says here that AE is a median to triangle A. Okay. So what they're saying is we've got a triangle A, B, E, close triangle, and AE is the median of which line? It can't obviously be any of those. It's going to have to be BE and ED. That's basically what they're saying to us. Okay. They're saying it in a funky way, but they're still saying it. Okay. Ooh, Lakuma fell on her keyboard. And now my chat is going crazy. Okay. What they're saying is that AE, so this line, AE is the median to that line, right? And the extra bit of information they've given us is that E is the midpoint of AC. So we can already look at the properties that we're going to be using here, guys. And then it says ABCD is prove that ABCD is a parallelogram. Okay. Median just means middle. That's what it means, Kiara. Median means middle. Okay, it's the middle of the line, the median. Okay, that's it. Median, middle. Okay, now we need to think about the properties that we know in this case. We're going to do a statement. Statement and reason. Okay. That's it. Tamsila's got the right idea. Okay, so we can say a couple of things about what's happening over here. We can start by saying that point E is a midpoint. Okay, that's statement one, the midpoint. And the reason for this is because they've given it to us. It's a given statement. What does point E tell us about all the other diagonals, guys? What does it tell me? Go ahead, pop your guesses in the chat. Nope. Kylie, is it Kylie? Yes. Kylie, this is grade 10 work. This is pure grade 10 work. Okay. If we know that E is the median, guys, we know that E is the median of both these diagonals. What is equal? What is equal? Avian, you can't just say things are equal. What is equal? Be very specific, guys. Tell me this is equal to this. Don't just say that things are equal. B and B are not equal. Actually, are they angles? What are they? I need you guys to be very specific. Thank you. Thank you, Nyeleti. But no, not AC and BD. They are not equal. That's it. Loken, you rock star. What they mean is that BE is equal to ED, right? And that is because of the midpoint. The midpoint of BE. Good. Yes, David. AE will be equal to EC. That is the midpoint. Again, it's the midpoint of AC in this case. Right. Now that we know that these two things are equal, we know that because they both pass through the point E, what does that tell me about BD and line BD and line AC? What does that tell us? That they what? What do they do? There's that one word. There's that one word I'm looking for. That's it, Sponga. That's it, Apiwe. They bisect. AC and line BD bisect. Absolutely. And this is 100% a property of a parallelogram. This is a property of a, okay. Of a parallelogram. We didn't even have to go far with this one. Therefore, ABCD is a parallelogram. Rebetu says, what does bisect mean? It means they cut each other, they intersect. That's what bisect means. Okay. Is a parallelogram. Okay. And the reason for this is that the diagonals bisect. Okay. All right. Okay. We're going to run out of time. I want to stop it there and I want to discuss something that Apiwe said before we get into trouble. Okay. Before we get into trouble. Okay. When I almost wrote properties of a parallelogram as my reason as to why this is a parallelogram, we are not allowed to do that up here. I cannot write ABCD is a parallelogram, properties of a parallelogram. No, I can't do that. The only thing I can do is, let's say, for instance, I'm answering a question. Let's say they give me a shape. And in my question, the question says, let me just go A, B, C. If in my question, the question says A, B, C, D is a parallelogram. Okay, parallelogram. And then let's say, for instance, they want us to find the length of BD. They have told me that ABCD is a parallelogram. Only then can I say, in my answer, I can then say BC is equal to AD, and my reason for that is properties of a parallelogram. Okay. I can't use that as a reason for my proof. Only if they tell me that it's a parallelogram can I then say properties of a parallelogram. Can I just get a thumbs up so that everybody understands what I'm saying here? Does everybody get what I mean when I say that you can't use properties of a parallelogram as a reason to prove for a parallelogram? You can only use it if you're using the property. Yes? Luyanda, what? Hi, Luyanda. Excellent. Okay, I'm very glad to hear that. Teacher Nels, I'm going to ask you to pop the link to the quiz in the chat. Don't worry, there are no proofs of that. We're only looking at the properties of quadrilaterals, so that will make it a little bit easier for you guys. We're going to pick this up on Monday again, and then we're going to start the midpoint theorem as well, because it's very necessary for us to do this. Okay, thank you so much, guys. Thank you so much, guys, for joining me this evening. I hope we actually learned something today. It's like parallelograms are not that easy. Okay, parallelograms are not that easy. I'm glad. Samuel says it was fun. I love it. Excellent. 9 out of 14 is good. Do it again, Emilio. Do the quiz again. Do it again until you get 14 out of 14. Good night, everybody. Okay, Tanipolo was saying, ma'am, please repeat. Tanipolo, if I'm writing the answer to a question, relax. I can't even. Oh, Emilio, we need to meet your puppy one of these days. Love puppies. You're very welcome. You're very welcome, Swonga. Tanipolo, this is what I'm saying. If it says to us, prove that ABCD is a parallelogram, I can't then go, E is a midpoint, and my reason is properties of a parallelogram. I can't do that because I'm proving that it's a parallelogram. I can't use the property of something I'm trying to prove. The only time I can use the word properties of a parallelogram is if they've already said ABCD is a parallelogram. Does that make sense? Oh my gosh, I must see. I must see.